So now we will see one more type of problem on simple RL and RC circuits. See the question, there is a 200 volts 50 Hertz inductive circuit which takes a current of 10 amperes lagging 30 degrees. When the question says it is an inductive circuit, it means it consists of L, and it may preferably, if it was a pure inductive circuit, then the angle would have been 90. But since it is between 0 to 90, so it might be an RL circuit. So most of the times in your examinations, we will be giving you either an RL circuit or an RC circuit or a combination of these three. But since if I insist that it is an inductive circuit, you take RL, okay, which means it is an RL circuit. And what else has been mentioned? See, this is the supply, and see, they have already mentioned the current which is flowing. I'll take it as R and L, and the current is 10 amperes and it is lagging by minus 30, which means it is 200 at an angle of 0, whereas this is 10 at an angle of minus 30. And they are asking you to determine the value of resistance and inductance and also reactance. Okay, now how to determine these parameters? Now, so if you see, the given circuit is an RL series circuit, and I have taken resistance and inductance as R and also L, right? So what is the impedance of this one? Normally the impedance generalized formula is this one, but here in case I don't have any capacitance, so I'll remove this one. So my impedance after ignoring the capacitance, this is my expression where XL is equal to 2 pi FL, or I can write it as omega L, right? So what is the source voltage which has been given? See, it has been given as 200 volts RMS, and the frequency is also given as 50 Hertz. From this, what we can calculate? Omega we can calculate, isn't it? So omega is equal to 2 pi F, which is equal to 2 into 3.141.250. I'll get 314.15. And also the current is being given as 10 amperes with lagging at 30 degrees, which means it can be written as 10 at an angle of 30 degrees. If V is at 0, then the current will be at 10 at an angle of minus 30. Okay. So when I speak about the current, since it is said that it is lagging, so which means that if voltage is 0, then the current will be at minus 30. If it was leading, I would have taken plus 30. Okay. So that's fine. Your current is 10 at an angle of minus 30. Now, it can be observed that your Z is nothing but your V by pi. Your V is already given it as 200 at an angle of 0, whereas current is now 10 at an angle of minus 30. So if I divide this thing, I'll be getting, this is 20 at an angle of 0 minus of minus 30, it is 30. This is your Z. If I write it in rectangular form, this will become 20 cos 30 degrees plus J 20 sin 30 degrees, right? So this is your R, this is your XL, isn't it? So this is your R, this is your XL. Okay. Now your R is 17.32 and your XL is 10 ohms, right? So once I do have my XL, how to calculate? Your XL is equal to 2 pi FL, right? You know the value of frequency, it is 50. So this is 10, this is 2 pi into 50 into here. So I'll get 10 by 2 into 3.14 into 50. So I'll be getting some value, right? See, the resistance of the circuit, reactance of the circuit is 10 ohms. And once I do have this, how to determine the inductance? See, 31.83 millihenry. So resistance is 10 ohms, XL is, resistance is 17.3, reactance is 10 ohms, L is 31.83 millihenry. Like this, you should solve the problems. Okay, I hope that now you are able to determine the response of RLC circuits, and I'm giving you some sample problems to work out at home. This is problem number 1, this is problem number 2. Solve this and come back to the class tomorrow. We'll solve some more numerical problems in the class. Thank you.